For thousands of years, humanity has looked into the night sky and wondered how everything began. Every generation built better instruments, hoping to see a little farther into the universe than the one before. But no telescope has changed our perspective quite like the James Webb Space Telescope. Launched to explore the universe in infrared light, Webb was designed to detect some of the oldest light still traveling through space. Because light moves at a finite speed, observing extremely distant objects is like looking back through time. The faint glow captured by Webb today began its journey billions of years ago, long before our solar system existed. Astronomers expected these observations to reveal a universe that was still in its infancy, a place where the first small galaxies were only beginning to form. According to current cosmological models, the earliest galaxies should have been relatively small, irregular, and gradually growing through gravity, gas accretion, and repeated mergers. Over hundreds of millions and billions of years, these primitive systems would eventually evolve into the majestic spiral and elliptical galaxies we observe today. But Webb's earliest observations introduced an unexpected puzzle. Instead of seeing only tiny, chaotic galaxies, researchers found several distant galaxies that appeared brighter, denser, and more developed than anticipated. Some seemed to contain surprisingly organized structures, while others appeared to be producing stars at extraordinary rates. These observations immediately attracted attention throughout the astronomical community. Importantly, they do not overturn the Big Bang model or established physics. Instead, they suggest that some galaxies may have formed and evolved more efficiently than previous simulations predicted. To understand why this matters, it's helpful to remember how galaxies are built. After the Big Bang, the universe consisted mostly of hydrogen and helium. Gravity slowly gathered these gases into dense regions where the first stars ignited. Inside those stars, nuclear fusion created heavier elements such as carbon and oxygen. When massive stars ended their lives in supernova explosions, they scattered those elements into space, enriching future generations of stars and eventually making planets possible. For decades, scientists believed this process required considerable time. Yet Webb has detected evidence that some early galaxies already contain surprisingly mature stellar populations and significant amounts of heavy elements. Using spectroscopy, astronomers analyze the light from distant galaxies by separating it into different wavelengths. Every chemical element leaves a unique fingerprint within that light. Through this technique, Webb has identified elements like oxygen and carbon in galaxies formed only a few 100 million years after the Big Bang. These discoveries suggest that stars were forming, evolving, and enriching their environments remarkably early in cosmic history. Exactly how quickly this occurred remains an active area of research. Some astronomers believe dense gas clouds, efficient star formation, and frequent galaxy mergers may explain much of what Webb is seeing. Others continue refining computer simulations to better reproduce these early conditions. Rather than creating certainty, every new observation encourages scientists to ask better questions. And that is exactly how astronomy moves forward. As Webb continued exploring the distant universe, another mystery began to emerge. Some of the earliest galaxies appeared to host enormous black holes far sooner than expected. Supermassive black holes, containing millions or even billions of times the Sun's mass, are commonly found in the centers of modern galaxies. Traditionally, astronomers believed these giants grew gradually over immense periods through the accumulation of gas, dust, and mergers with other black holes. Yet several distant galaxies observed by Webb appear to contain massive black holes at an unexpectedly early stage of cosmic history. Researchers are now investigating several explanations. One possibility is that unusually dense gas clouds collapsed directly into massive black hole seeds without first forming ordinary stars. Another idea is that black holes in the young universe experienced exceptionally rapid growth because early galaxies contained abundant gas available for accretion. Neither explanation has been confirmed, and both continue to be tested against new observations. Webb is also transforming our understanding of cosmic chemistry. Its infrared instruments can detect molecules hidden inside clouds of gas and dust that were invisible to previous telescopes. Among these are complex carbon-containing molecules found in distant galaxies and star-forming regions. These molecules are not evidence of life. However, they demonstrate that many of the chemical ingredients associated with planetary systems became widespread surprisingly early in the universe's history. This suggests that the building blocks required for complex chemistry may have been available long before planets like Earth existed. At even larger scales, Webb continues mapping the immense structure of the universe itself. Galaxies are not randomly distributed through space. Instead, they gather into clusters connected by enormous filaments that stretch across hundreds of millions of light years. Together, these structures form what astronomers call the cosmic web. Gravity shapes this vast network over billions of years, while invisible dark matter provides much of the underlying gravitational framework. Some newly observed structures are still being compared with advanced cosmological simulations to determine how closely they match theoretical predictions. At the same time, Webb's infrared vision has revealed stellar nurseries hidden behind thick clouds of dust. These observations allow astronomers to study how stars are born, how planetary systems begin forming, and how galaxies continue evolving across cosmic time. Perhaps Webb's greatest achievement is not proving that existing theories are wrong. Instead, it is showing scientists where their models need refinement. Modern cosmology remains remarkably successful at explaining the universe on large scales, but Webb is revealing details that require more precise understanding of galaxy formation, black hole growth, and early cosmic evolution. Every observation extends humanity's map of the cosmos while revealing new regions of uncertainty beyond it. The James Webb Space Telescope was built to answer some of astronomy's oldest questions. Instead, it has uncovered entirely new ones. Each image reminds us that the universe is far richer and more complex than we once imagined. And as Webb continues peering deeper into space, and further back in time, it is becoming increasingly clear that the greatest discoveries may still lie ahead.